Example review, part 1. Let's move on to page 2, solving differential equations. So we have this differential equation. First, check to see if it's separable or not. Obviously, it's not a separable differential equation. Here, if you factor out y or 2y, and then you end up with another y plus a term in x, so we cannot separate this. Is it linear? Well, check to see if it's linear or not. If we separate these fractions, you end up with y squared plus 2x on the denominator. Since we cannot separate these two, we cannot simplify this. So it seems like it's not going to be linear. What about exact? Let's check to see if it's exact or not. Well, first of all, you need to write this in differential form, mxy dx plus nxy dy equal to 0. So just using simple cross multiplication. Here we have dx times 3y squared plus 2x. And this negative sign to the right-hand side gives you plus. Your n becomes 4y squared plus 6xy dy equal to 0. Now you need to check to see if the partial derivative of m with respect to y is equal to partial derivative of n with respect to x. Partial derivative of n with respect to y, it gives you 6y, and this is just 0. Partial derivative of n with respect to x, this guy is 0, and this is just 6 times y. So they are equal to each other. We have an exact differential equation. It means that we can apply the method of using an exact differential equation to solve this ODE. How do we do that? You have a function in x and y which is equal to the integral of m dx. So f of x and y becomes the integral of m3 y squared plus 2x dx. This becomes 3y squared x plus x squared plus a constant of integration, which is not just c. It must be a function of y because you have a function in 2 variables. Then you take the derivative with respect to x. This acts like a constant. It becomes 0. In the next step, take the partial derivative of f with respect to y, and it must be equals to your n. So we build f some part of it. You have 3y squared x plus x squared plus gy. Partial derivative of f with respect to y. So I'm going to write this here. Partial derivative of f with respect to y becomes 3y squared x, 6yx. This is going to be 0 plus g prime of y must be equals to n. But what is n? N is 4y squared plus 6xy. Well, we can cancel out these two terms. It's just equality. So g prime of y is equal to 4y squared, or g of y, which is the integral of 4y squared, becomes 4/3 y cubed plus a constant of integration. So f, this function in x and y, becomes 3y squared x plus x squared plus g, which is 4/3 y cubed plus c. Now the solution of this differential equation can be written as 3y squared x plus x squared plus 4/3 y cubed equals to a constant